Hello students, welcome to today's IMK's BMSAT series. So in this video we are going to cover functions. So in functions generally the problems are limited to domain and range only, but sometimes they may go to minimum and maximum values also. But most students confuse that with inequalities. Yes, functions can be related with inequalities also, but there are some problems which you have to know, like the models which you have to know, which are related only to functions. Okay, so if you understand that, how the questions can be asked in functions, you can know like what to prepare and what not to prepare. So fine, as IMK's syllabus has said, like they are going to give some algebra questions. Functions will be one of the major part in that. Not only in that, wherever logarithms are there, progressions are there, and inequalities are there, these functions will come handy. So the logic here we're going to discuss is coming very helpful for you in the in the next classes also, like logarithms and everything. So let's start today's class. So in this we're going to cover domain and range and algebraic functions, under root functions, exponential, logarithm functions. How to find domain and range for all of these. I hope you all know what is domain and range. If not, let us discuss for some time. Domain is nothing but all those values which can be taken in place of x. What is x? Here x is nothing but a variable on which the whole function is dependent. Let me say one thing. Let me write a function. So let us say a function f of x is defined as x square plus 2. This is the definition of the function, right? It depends on the value of x. It is not depending on the value of 2, right? Okay, 2 cannot change. 2 is constant. So it does not depend on value of 2. It does depend on value of x square. If x square rises, the value of the function also rises. If it decreases, value of function also decreases. So here, what all values can be taken here in x, in place of x? That comes as your domain. Okay, and some people even now they get confused between codomain and range. Are they same or are they different? Yes, exactly, they are different. So codomain, what is codomain and what is range? Okay, now if I take some values of x, for example, there is a limit for domain also. I cannot take n values of domain. I cannot take infinite values of domain. Okay, only some values where this condition or this function exists, that is only my domain. Okay, I cannot take infinite. Okay, I cannot take undefined terms and say this is a function. No, not at all. Function, every function cannot be defined all over. Okay, they have some limitations. In those limitations, the values of x are called as domain. Okay, in that domain, that particular values of x, if I take the values in place of x, the whole value of f of x, okay, when I take value of x, the whole value of f of x will change. In those values, the maximum and minimum and this range or the between numbers, the whole thing is called as range. Understood? Let me repeat that again. If I take the domain values in function in place of x, I'll get some values of f of x. Those values ranging from minimum to maximum, maximum to minimum will be my range of that function. Okay, but coming to codomain, what is this codomain? This codomain is nothing but the range included with other numbers. That means there will be some numbers or some values out of range. Okay, that is called as codomain for us. So these definitions are very important when you are solving these functions. Sometimes basic functions can also be asked. What is one function, one-two function, on-two function, into function? Okay, so you have to understand the definitions of a function first. Okay, now we are going to see some functions which are called as onto function, into function, bijective, surjective. Okay, why these functions are important? There are instances where these type of questions were asked, so you have to know what is onto. Okay, now I'm not going this whole class to explain all these things. I'm going to leave you with some clues, so that you can go and check in the internet and comment those things in the comment section. What are they? Let's see. This onto, into, bijective and surjective do have only one common difference in all these things. What is that? It's all about codomain, domain, range. Okay, you understood codomain, domain and range, right? In that, if codomain is whole equal to range, I already said that what is codomain, both are not same. But what if all the elements in the range were equal to codomain? What if that is the case? That type of function is called as what? And similarly, domain is equal to codomain. That means every domain number or element in the domain do have a merge in codomain. What is that case? So these things differ in only these ways. Okay, so these are the things which you have to know by yourself, because even if I explain here, it may take more time, but I'm skipping that. You have to know about all these things by yourself. But I seriously doubt these things will come in the examination, but they are basics. Okay, so another basic, coming to another basic, that is brackets. How to use brackets? So many of you may even now confuse about open bracket and closed bracket. Okay, if you know this, comment in the section. But what is open bracket? If you don't include a number, right? Or should I include the number? What is the meaning of this? 3 included or 1 included? I mean, I should not write in the number system like this. I should write in a number system way. Okay, in a number line series. -3 comes first, then 1. Okay, -3 and 1. What is this thing? And what about this? Okay, so comment about these things also, about the brackets. I hope you know all these things. These are very basics. If you don't understand that, please comment in the comment section so that I'll provide a new video clearly explaining those onto, into functions and these brackets also. Okay, this is very small, that's why I'm going to explain this. -3, 1 means -3 should not be included. The values which are near to -3 but greater than -3, where -2.99, -2.98, even you can expand even more than that. So these values were there, but not -3. Only -3 is excluded, and these whole values are there. And coming to this closed bracket 1, that means I have to include 0.98, 0.99 and 1 also. This closed bracket meaning is I have to include that value too, and here -3 is excluded. Okay, this is the meaning of this. And what are the flower brackets? Comment that. Okay, so domain and range are nothing but limitations of a function. So when you see a function, for example, do I have a slide about that? Yes, I do have a slide. So the domain of a function f of x root over, this is a root, right? So I'm writing it as like this. So root over x plus 1 x minus 3 divided by x minus 2. So I have to define this function. So listen carefully, don't think that these are very easy. These are the critical problems where you can go wrong. Okay, so observe this carefully. I should know the limitations of this function. This is a definition. This is the definition of this function. That means functions are varying. A function is varying in this way. It is dependent on value of x, and x value has been designed in this way. Okay. Now, what are my limitations? That gives my codomain. So the limitation, if I find this limitation, I'll get my codomain. First of all, to make this exist, to make this function exist, what should be the minimum criteria that it has to satisfy? This should not be equal to 0, right? So x should not be equal to 2. This is my first limitation, limitation 1. Okay, now coming to the next one, it is under root. This whole thing is under root, x plus 1 into x minus 3. What is the minimum criteria for any function, for anything to be under root? It is greater than or equal to 0. It cannot be minus. Okay, if this whole thing is a negative, it is undefined, or we can say that they are imaginary numbers, right? So they are not real. So x plus 1 into x minus 3 should be greater than 0. Okay, this is into. That means they have to be positive or should be 0. That means x plus 1 can be negative, or at the same time x minus 3 can be negative. Then only it can become positive, isn't it? If any one of those things can be equal to 1, can be equal to 0 also at the same time, because any 0 into anything can be 0, or both should have the same sign. These are other two conditions. So I can take it as like this. Or they both can have same sign, means they can be positive also. Right? So these are the limitations that one have to follow. This is the first condition, this is second condition, and this is the third condition. Right? Now on a number line, this is 0, this is y-axis, this is x-axis, these have positive values and these are negative values. So on this number series, this is positive direction, this is negative direction. I have to see the critical points. What has to be included? Sorry, excluded. 2 has to be excluded, right? Isn't it? So I am excluding 2. This is 2. Okay, 2 is excluded. And what is there for this one? This condition, x plus 1 less than or equal to 0. That means x should be less than or equal to minus 1. Okay, if this is minus 1, it can be equal to minus 1. If it be equal to minus 1, it will become 0 and it will be okay, because it can be 0, but it should be less than minus 1. That means it has to be in this way, right? It has to have these values, 1 included. Okay, less than or equal to minus 1. Fine. And next, x minus 3 less than or equal to 0. That means x less than or equal to 3. Okay, if this is the value of 3 less than, okay, this one, this whole system, and yes, we have to exclude 2. Okay, 2 has to be excluded, remember that. And coming to this condition, x plus 1 greater than or equal to 0. That means x greater than or equal to minus 1. So that means this thing, this whole values. And x minus 3 greater than or equal to 0. That means x greater than or equal to plus 3. That means this value. Okay, so I hope you understood this whole thing. What are the limitations now? What is the domain of this function? What values I can take in x? I can take any value of x. See, I can take, you can check that also. Let us check with 0. If I take 0 here, it will be 1 into minus 3 divided by, that means minus 3 divided by 0 minus 2, it's minus 2. So let's see the solution of this one. So whenever x is less than or equal to minus 1, the other criteria should be satisfied is this one. That means x should be less than or equal to 3. So this is not epsilon, this is less than. Okay, that means, see, if you take the value of 0, which is actually greater than 1, greater than minus 1, and less than or equal to 3. So if I take 0 here, this will become 1 and this will become minus 3 and this will become minus 2. Is it satisfied? No, because under root I have a negative value. That means when x is less than or equal to minus 1, on parallel it has to take other values of x less than or equal to 3. Okay, so what is the common part here? The common part is minus 1. If I take start from minus 1, let's say if this is minus 1, it will become 0, so the whole will be 0, it is okay. But what if I take minus 2? That means less than or equal to minus 1. If I take minus 2, it will be minus 1 and it will be minus 5. So when I multiply both of them, it will be positive, right? And this is also defined, minus 2 and minus 2 is minus 4. Yes, I can divide the root with minus. Okay, the value under root should not be negative. Okay, so minus value of this whole thing can be valid. That means from minus 1 to infinite, okay, this is valid. On the same place, in the same way, this whole thing, even this has to be valid, right? Because this thing has to be positive. For that being positive, either the two values has to be negative or the two values has to be positive. That means x should be greater than or equal to minus 1. That means this part. And x is greater than or equal to 3. That means this part. The common part here is starting from 3 comma infinite. Sorry, 3 has to be included and infinite has to be excluded, because we don't know the values of infinite. So that's why we are using open bracket rather than close bracket. Again, check for are all conditions. Is 2 included in our answer? No, right? That means our answer is right. Because if 2 comes in this answer, you have to remove the 2 also. Okay, but 2 is not excluded here, so that's why our answer is right. It's minus infinity comma 1 union 3 comma infinity. Why I'm deliberately saying these things because in Indore recently they have asked a question on the finding a domain. In that, most of the students have left it or they answered it wrongly, because the answer is null set. They don't have any common areas to prove the answer. So like this, we do have a common area here and here, so that will be our answer set or the solution set. In that question there was no a common answer, okay, a common area to prove. So that's why it was null set. Okay, if you don't have any common area, the answer will be null set. Okay, fine guys, so let's go to the next question. Okay, why this question came here I don't know, but I think you can do this one. The coefficients of the sum of the coefficients of all the terms in the expansion of 5x minus 9 power 4. 5x minus 9 power 4. Okay, whenever you want to find the sum of the coefficients, actually you can expand this, right? 4c0 into 5x power 1 into power 4 into minus 9 power 0 plus 4c1, like that you can add everything. Okay, you will get everything in terms of x power 4, x cube, x square, like that. But it will be a very hectic process. Instead of that, you can take x as 1 here. Okay, then it will be 5 minus 9 power 4, that will be minus 4 whole power 4. Okay, so answer will be 256. But why have to take 1 as a value? To find the sum of the coefficients of any expansion, of binomial expansion or trinomial expansion, you can take the value of 1. Okay, then you will get the answer. Okay, Yes. Okay, for this I think they have given this one in the previous question. So the given question is, if minimum value of f of x square plus 2bx plus 2c square is greater than the maximum value of g of x square minus 2cx plus b square, then for real value of x is, okay, understand this carefully. Even though it is looking like a quadratic equation, I mean, they are looking like functions, they are quadratic equations, isn't it? You can find the answer by using your quadratic equation knowledge. In the previous videos, we have discussed how to find minimum value of a quadratic equation. What is meant by minimum value of a quadratic equation? It is nothing but the vertex of the quadratic, I mean, parabola. Here, the parabola is up, I mean, it is open upwards. That means what is its minimum value? Minus b by 2a. That is the vertex. So apply that. Minus b means this whole thing. It's minus 2b divided by 2a. Okay. At this point, that means f of x, f of minus b will be giving us the minimum value of the given function instead. Okay, let's substitute that. So let us substitute minus b here. It will give us b square minus 2b square plus 2c square. Okay, that means 2c square minus b square. Let us keep it here. 2c square minus b square is the minimum value for this one. The maximum value of the other function, that means it is up or down, right? That means here also minus b by 2a, that is minus 2c by 2, that is minus c, and that means f of minus c will give me the maximum value here. So that gives me c square minus 2c square plus b square. So that gives me b square minus c square. Alright. So here the condition given is the minimum value of this is greater than the maximum value of this. That means we can take it as like this. So after solving this, I'll get it as 3c square should be greater than 2b square. Have I done right thing? Please check it. C square minus 2c square. Actually the question, I mean, even I have done wrong here. It's minus c. So if I multiply minus c here, it will become 2c square. But somewhere the question is wrong, saying that this has to be minus, right? Then only it will be upward down. Then it will become minus c square, because even though it squares minus c, the minus coefficient is there itself. So it is b square plus c square. Okay, the whole value at this point is b square plus c square. That is the maximum value for this function. So yes, let's substitute that. So b square is greater than b square plus c square. That means c square has to be greater than 2b square. Okay, that means if I take the whole root on both sides, it will be mod c should be greater than root 2 over mod b. Okay, so this is a solution for this thing. That means we have found the limitations of the given functions by applying quadratic equations formulas. That is minus b by 2a, which is the least point, or the least value or the minimum value for a quadratic equation, or maximum value for that quadratic equation if it is upward down. Okay, so in this way we have found these values. Okay, let's go to the next one. Okay, set of all real numbers x for which x square minus mod of x plus 2 plus x greater than 0. Yesterday we have, previous classes we have done the same thing about the quadratic equation. So we can apply that here. So comment your answers about this function. How to see this one? You can take it as two functions. One is directly and the other is x square minus of minus x plus 2, which is x plus 2 plus x. Okay, so the real numbers x, the set of all real numbers of x for which this is greater than 0 is, that means you have to prove minus x minus 2, if this is expanded it will be minus x minus 2, so x and x gets cancelled, so you will get two conditions, that is x square plus x square minus 2 greater than 0, and another is quadratic equation x square plus 2x plus 2 greater than 0. I hope this question is it's not marked, let's say it's fourth question. So comment your answers in the comment box about this thing. We have solved this one in the previous classes, so I'm checking your knowledge. This is a set of all real numbers, that's why this is asked in functions. So in quadratic equations we already solved this type of problem. Okay, so I'm asking you guys to solve these two and get the set of all real numbers of x for which this is valid. Okay, let's move to the next one. Okay, now even like the functions can be asked on trigonometry. Okay, because trigonometry is a type of function. In trigonometry the identities play a key role, like this: cos x plus cos y equal to 1. The range of sin x minus sin y is. Okay, given this we have to find this value. So understand this, given that cos x plus cos y equal to 1, so whenever any identity is given like this, try to understand or try to apply your trigonometry knowledge. So we are not discussed trigonometry yet, but let's try to solve this one. So cos a plus cos b equal to 1. It's like cos a plus cos b equal to 1. So can I get it from cos of x plus y by 2 into cos of x minus y by 2? This is nothing but 2 cos a cos b can be expressed in this way, isn't it? So yes, if this is equal to 1, I can say that, I'm taking this whole value as a and this whole value as b. So cos a cos b is equal to 1 by 2. Okay, with this I can apply for this one also, the same style. 2 cos of x plus y by 2 into sine of x minus y by 2. Okay, that means 2 cos a sine b. Let us take this as some value p. That means cos a into sine b is equal to p square by 4. Okay, sorry, p square by 2. P by 2, sorry. Y square is. Okay. Next, let's solve these two things. We want the value of this one, the value of p, because that is the value of this one, which is the value of this. Okay, so I want the value of p. To solve this one, what I am doing, I got cos a cos b here and cos a sin b here. So cos a is common. If I take cos a common, I'll left with sin a and sin b and cos b, which gives me an idea to making them cos square theta plus sin square theta. If I can nudge them to go into that equation, I can easily solve the whole thing. So let's square on both sides. So it is cos square a. I am taking cos square a common directly. So it's cos square b plus sin square b. Okay, but be careful with these values. 1 by 2 will become 1 by 4 after squaring, plus it will be p square by 4. Okay, so this will become 1. So that means, oh sorry, I have to rub this. The cos square a is equal to p square 1 plus 1 by 4. But what are the values? What is the maximum value of a cos square a? It will be plus 1. The maximum value of cos square a is plus 1. The range of cos a will be minus 1 to 1. But cos square a is only 0 to 1. The range is 0 to 1, the maximum value is 1. So can I write this as less than or equal to 1? Yes. So p square plus 1 will become less than or equal to 4. Yes. That means p square is less than or equal to 3. Exactly. That means this whole value will be p less than, I mean this is p, right? P less than or equal to root 3, isn't it? If I take root, it will become plus or minus. So the answer is this. The range is that, the value. Okay, when I take x and y some other values, I'll get the whole value of this function as from minimum to maximum as this. Okay, in this way we will solve this functions. These are all IPMAT previous year questions, so they are from multiple examinations, from different examinations. So this is the way BBA entrance exams can be asking your domain and range. So that's why we are solving all this. Okay, let's go to the next question. Okay, see this. For a greater than b greater than c greater than 0, the minimum value of the function f of x is mod of x minus a plus mod of x minus b plus mod of x minus c. So generally, even in your Kozhikode examination, I am hoping that they will give this mod functions. Okay, if you can get the logic easily, it is okay. But if not, try to have values here in place of x itself. Okay, if they give numbers in place of a, b, c, try to have a value between the largest number and the smallest number in the given numbers itself. For example, mod x minus 1 plus mod x minus 2 plus mod x minus 3. Okay, then if they ask the minimum value, try to take numbers for x. That's what I'm saying now. Okay, but here there are no numbers. They have given a, b, c. So what to do? So they said a is greater than b is greater than c is greater than 0. So in place of f of x, in place of x, I am taking a, f of a. Let us see what can be the answer. So this will become 0. This will become mod of a minus b, and this will be a minus c. Okay, a minus b, will that be a negative or positive? It will be positive only. Okay, here in the question they said that. And what about a minus c? Again, it will be positive. No need to worry about it. Next, what is f of b? Again, if I substitute it, b minus a, obviously it will be negative. So minus of b minus a. Okay. Okay, fine. Let's take in mod on. Okay, plus mod of b minus c. This will be positive. Okay. That means this value will give me, the output will be 2b minus of a plus c. Next, f of c. Same. It will be c minus a mod plus c minus b mod plus 0. Here again it is 2c minus of a plus b. Okay. Now, whenever you observe this carefully, whenever you take these answers totally, you will understand. I mean, if you consider these values also, you will get this option 2c minus of a plus b. We have taken is more whatever we taken is modulus. So that means c here is very less. Even if it is double, you can say that a plus b can be the minimum value. Not this, because 2b minus a plus b, a plus c, obviously it is greater than c. So b minus c can be okay, but b minus a can be somewhat less, but not that exactly. Okay. So for this function, a plus b minus 2c will be the minimum function. Okay. Please check for any other discrepancy here. A minus b plus a minus c. Obviously 2a minus of b plus c. Okay, they are all positive, but we don't know how much like more than 0 they are. They can be less than 1 also. Okay, so that's it guys. So that's it, guys, in functions. Please understand the nature of the questions that were asked in the exam, in these examinations, and try to solve the models in this line. Okay, then you can know what can be asked and what not be asked, and you can touch only those questions which you know in the examinations. Because every time I say this in the classes, that your examination is going to be around 1 hour for 50 questions. That means in these 50 questions you have to solve, you have to pick the things. So for picking up the things, you have to be very aware about what is easy for you and what is known to you, what is not known to you. These questions will come in your examination. That's for, I mean, that's my gut feeling. So when you see these questions, don't try to leave it, because they look harder but they are very easy. Okay, fine, guys, try to solve this question and answer in the comment box. Thank you.